Hey guys, this is part one for your semester exam review. This is for I can't do this.
Not even in the room.
Hey guys, this is your semester exam review part one. There are 3 different parts. The first 8 problems will be done by me, Miss Pascual. The next 8 or so problems will be done by Miss Elizondo, and then the last part, part 3, will be done by Miss Pettis. Just remember, this review is very important. This is your semester exam worth 20% of your grade. I know you keep hearing this over and over again. But we structured this review so that this will help you. This will cover all the topics on your exam. Right? And it's structured pretty much like it. Right? So if I were you, pay very close attention. We are here to help you. Alright. Number 1. Number 1 says, determine what type of correlation each scatter plot has. Then draw the line of best fit of the information. In correlation, we have either positive, negative, or no correlation. Alright, those 3 options. Looking at this first graph, cookies in the jar, we see that if we were to draw a line of best fit, meaning we take the average of all the points and draw a line so that I have the same number or amount of points below my line as above it, I see it's going from left to right in a general downward direction. If it's going down, it's a negative correlation. Your answer is negative. Let's look at this next graph. From left to right, I can see that it's going in a general up direction. Okay, so if you were to draw your line of best fit, it's about the same amount of points above the line as below the line. I can see it's going from left to right, it's going up. Therefore, positive. Positive correlation. As the temperature increases, of course, there's more visitors at the beach. When it gets hotter, there's more people going at the beach. So when both are increasing, that is a positive correlation, a positive relationship. However, let's look at this third one, lifeguards. Okay? The temperature of the water versus the number of lifeguards. As we can see here, it's neither going up nor down. What's left? No correlation. So let's move on to number 2. This one was a little tricky, but with these types of word problems, it helps just to read. And hey, look, they give you your equation. So guys, just a reminder, the EOC and the benchmark and this test, our midterm, it's multiple choice. So we can use the process of elimination to increase your chances of selecting the correct answer. So that's the biggest flaw. We give you the answers. You just have to find it. On number 2, it says here, Nicole spent $12 in a candy store. Alright, so I'm going to circle this one because that's important. Alright, she spent a total of $12. And over here in my equation, I have a total equals 12. Okay, so that's where it is in my equation. She spent $1.16 more than twice as much as she spent on mints than on gum. Okay, this is another algebraic expression. This is important, so I am going to circle this. So down here in this equation, this quantity is located right here. So what's great about this problem is that you don't have to come up with the equation yourself. It's given for you. She spent 3 more on chocolate than on mints. So I'm going to use green. And that quantity is located right here. Okay. She spent $3 more on chocolate than on mints. The equation below represents this information where M is the amount of money spent on gum. Just remember, guys, M is the amount of money spent on gum. This is gum. So let's label what we have so far. Okay, we're trying to interpret what this equation really means. What is given to us? M is the amount of money she spent on gum. This quantity right here is the amount she spent on mints. This quantity in green is the amount that she spent on chocolate. And that's her total. So when we're reasoning through this, we can see, oh, she bought three different things. She bought gum, mints, and chocolate, and she spent a total of $12 on those. Just remember what the question is asking how much money did she spend on mints. So guys, anytime you have an equation and you have one variable, one unknown, you can solve it using algebra. I'm going to go ahead and rewrite this equation over here onto the side. So first, in your order of operations, PEMDAS, please enjoy my dad's armpits slowly. The first step is parentheses. I need to get rid of the parentheses. So in parentheses, what number is really outside of these parentheses? If there's no number, we automatically assume it's a 1. Same thing here. But if you were to multiply any number by 1, that quantity times 1 is itself. So I really don't have to go ahead and distribute 2m times 1 and $1.16 times 1 because it'll just remain the same. So all I really need to do is just take out the parentheses. I don't need them. Those are just there for the grouping purposes of saying, hey, this is gum. Hey, this is the amount I spent in mints. And this is the amount I spent on chocolate. I'm just going to rewrite it so that it's a little cleaner. Before we begin, we want to make sure that either side of your equation, you can neither combine like terms nor distribute. But hey, look, we have m's. And we have naked numbers. I have 2 different types of terms. So when I combine like terms, this is technically 1m. This is 2m, and this is 1m. 1m plus 2m plus 1m is 4m. And what I am left with is $1.16 plus 3. Those are like terms. So if you add those, you get $4.16. So just bring everything down. Now, hey, you're down to your 2-step equation. First step, box in your variable and anything that's attached to it through multiplication or division. Now, we want to get this quantity by itself. We want to ultimately get m by itself. We want to solve for m. So thinking outside the box, I need to do the opposite operation. I need to get rid of this $4.16. And to do that, I subtract it. Because they added $4.16, I subtract it. So what you do to one side of the equation, you do exactly the same to the other side. Now we are left with 4m is equal to $7.84. You can use your calculator, guys. Don't be afraid of using the calculator. Now, we want to get m by itself. So they multiplied m by 4. So to get rid of this 4, opposite of multiplication is division. Divide by 4. Divide by 4. I am left with m is equal to $1.96. Oh, is that my answer? No, guys. Read the question. M represents what? It represents the amount of money she spent on gum. This is gum. The question is asking how much money did she spend on mints? Trick question. All right, but we know the quantity that she spent on mints. It's this one right here that we circled. But we know the m value now. All we have to do now is plug it in. All right, so let's take this. I have 2 times whatever I got for m, which was $1.96. And I add $1.16. It does give you $5.08, and that is how much you spent, or she spent, on mints. So guys, read the question. Make sure you're answering the correct question. Alright, number 3. So we're given list of table values where over here we have the size of the lawn in square feet. And then over here on the right side I have the fertilizer required. Which equation best represents the relationship between S, the size of the lawn, which is what we just labeled it as, and F, the pounds of fertilizer required? Again, the flaw with the test is that, hey, it gives you the answers. Okay, so looky here. We have equations and it only gives us the slope. Given a table, we can find the slope. We can use bird-beak method. Remember guys, your slope is the changes in y's divided by your changes in x's. In order to get from 0.5 to 1, you had to add 0.5. This is your changes in y's. In order to get from 50 to 100, you had to add 50. This one is your changes in x's. The first column is your x values, and the second column is your y values. But we have it in terms of s and f. Don't let that confuse you. Plugging it in here, my changes in y is 0.5. My changes in x is 50. We get 0.01. Now, don't freak out. Look, the answer choices, they're given to you. They are mostly in fraction form or whole numbers. We can change this decimal to a fraction using your calculator. So anytime you want to find a fraction or even reduce fractions, you can go press math. Enter, enter. What you are left with is that fraction. And well, what do you know? The only one that shows it dividing by 100 is G. G. That wasn't so bad. Haha. Anyway.
What was that?
It's a pun. So there was another way that you could have done this given the answer choices. And guys, remember, use the answer choices to your advantage. So let's say you did choose G, but you were not sure. You are given the table values. You can just plug it in and see which one works. Alright? So for example, let's plug in the value of s as 50. Okay? 50 divided by 100, that gives me 0.5, which is right here. The next s value, 100, divided by 100, just like using your formula, it does give you 1. Okay? So if you were to do that for the rest of these table values, it would have worked. It satisfies. Number 4. So really all the question is asking us to do is find p, and they even give you the equation. Oh, well, what do? Solve. So again, what you do when you solve equations first is make sure that either side of your equation is completely simplified, meaning you can neither combine like terms nor distribute. Okay. This side 22 is just 22, but on this side, we know what 4 times 4 is. 4 times 4, 16. Bring everything else down. Oops, this is 1.5. P is equal to 22. Right? Now, we are left with our two-step equation. So we're going to box in our variable and anything that's attached to it through multiplication and division. I want to get p by itself on one side. That's what we do when we solve. They added a 16. To get rid of it, I do the opposite of what they expect. Instead of adding, we're going to subtract it. And what you do to one side, you do exactly the same to the other side. Right. So now you are left with, on the left side, 1.5p is equal to 22 minus 16, which gives you 6. Alright, now we're down to our one-step equation. They multiplied by 1.5, so to do the opposite, I divide by whatever number is next to that letter. I am left with p is equal to, and when you divide this out, you do get 4. Your answer is A. Number 5. What is the linear parent function? Alright, this was in our notes, and it was even on a foldable where we discussed parent functions. We had linear, quadratic, and exponential. But what we remember from linear parent function is that we have y equals x. That is my linear parent function. First, let's graph it. Okay. So remember, whenever you're graphing lines, remember linear has the word line in it. We have it in the format y equals mx plus b, where m is your slope and b is your y-intercept. That is the slope-intercept form, because it gives you your slope and your intercept. Pretty straightforward, huh? Okay, So in y equals x, our parent function, our slope is the number that's next to our x, the coefficient of x. And if it's just x, we automatically assume it's a 1, because 1 times anything is itself, so I put it there. Okay. And then what they really added was a plus 0. So this is the same exact thing as y is equal to x, but this can help you remember how to graph it. First step in plotting lines, plot your y-intercept. So your y-intercept is this number right here at 0. Now, the next step is do you rise over run, your slope. The slope being your m value. So, oh, how much do you rise and how much do you run? Right? If it's not in fraction form, force it to be a fraction by putting it over 1. Something divided by 1 is itself. We're not changing anything. So that means I have to rise a positive 1 and then run a positive 1 to the right, positive values. So using my y-intercept as a starting point, rise 1, run 1, rise 1, run 1, etc., etc., until you run out of room. Okay? Oh, but if you want to go the other way, you just do the opposite. Instead of going up 1, you're going to go down 1. And instead of going to the right 1, you're going to the left 1. So same thing here. Down 1, left 1. So now we have our graph of our linear parent function. It's going forever and ever down here and forever and ever up here. So the domain is the set of x values. So we're going to set this inequality up. X is in between 2 values. Okay? So the set of x values is, or our domain is where my graph exists from left to right. This arrow signifies it's going forever and ever and ever. So really, it's negative infinity. It never really starts. It just keeps going and going and going and going that way. And so we scan towards the positives now, and we go to infinity. That is where my graph exists. Now for the range, range is a set of y values. Y is in between 2 numbers. So whenever you're finding your range, again, you scan from the bottom to the top, from the negatives to the positives. Always, with your domain and range, it's always scanning from the negatives to the positives, from smallest to largest. So it starts off all the way down, 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 up, negative infinity, all the way up to positive infinity. And there you have your domain and range. Letter E, what is the slope of the linear parent function? Oh, we already found it. Remember, m is the slope, b is the y-intercept. So we already found that our slope is 1. That's the rate of change. This one says, what is the y-intercept of the linear parent function? Y-intercept, remember, is where your line crosses the y-axis. And it happens to be at 0, 0. Remember, your y-intercept or your x-intercept, those are actual ordered pairs. Those are actual points. So listed as an ordered pair. So the x-intercept, or where my graph crosses the x-axis, that is also at 0, 0. Do not freak out. They can be the same, right? But the only time it's the same is when it's at the origin. Let's do number 6. Speaking of domain and range. Okay, so we're going to, what I highly recommend you guys doing is creating a rectangular window. It narrows it down where your graph exists. I'm going to think of like your iPhone and, oh, you want to see this picture? Oh, I'm going to zoom in. You're only interested in that picture. So we're specifying that we're only interested in where the graph is. That is what domain and range is. So remember, domain is your set of x values. So x is in between 2 numbers. Okay, we'll set them all up like this. And range is in between, or is your set of y values, and it's in between 2 numbers. So domain, we scan from left to right, from the negatives to the positives along the x-axis. So just like we're using a scanner, where does your graph start? Your leftmost bound is right here when x is -3. Remember, domain is your x values. Look along the x-axis. It starts at -3. Right? And it is not included because of this open circle. So I am not going to put a line in my inequality. Guys, remember, the only time it is not included is when there's an obvious open circle or infinity. Every other time, it'll be included. Right? So we started on the left, and then up it stops right here when x is 6. There's also an open circle here, so it is also not included. Now for the range, remember the Drake song, started from the bottom, now you're here. Start at the bottom where the negatives are, or the smallest number. Your y value, the lowest point on your graph is when y is -1. And it's an open circle, so it's also not included. And you scan here, up. Your graph, the highest point is when y is a +5. Also not included. Alright, so for the next graphs, these two graphs, hey, you! Do this problem now!
Why?
Remember in class when you ask, hey, when am I going to use math in real life?
I guess.
Here's your opportunity.
Okay, so what am I doing? Okay, by the looks of this graph, it looks like we have two endpoints. We're going to have a pretty well-defined domain and range. So starting with domain, we're just going to look at the far left point, which is right here, and the far right point, which is right here. For now, I'm not going to worry about whether the spot is open or closed or whatever. I just want to find out what those spots are. So for the domain, the leftmost point is here at -5, so I'll just write that here as my lower bound. The farthest most point, or the furthest point to the right, would be at x value 6, so that'll be placed here. At this point, I just place my x in the middle. Now I just have to define whether or not the far left and the far right point are going to be included as part of the domain, or it's going to be left out. So between the -5 and x, clearly there's going to be that less than sign, but because the point is closed, there's also the equal sign, so -5 will be less than equal to x. Now for the 6, the relation is that because it's an open point, it's only going to be a less than symbol by itself, not equal to indicate that it's not included as part of the domain. So this is our domain, -5, less than equal to x, and less than equal to 6. Now for the range, it's a little bit tricky here because this has a bit of a wave pattern to it. But it's the same as the domain, but instead we're looking at the bottommost part, which is here for this line, all the way to the topmost part, which is at this point. Now here, remember range, we're looking at y values. So at this spot here, which is the lowest point on our graph, the lowest y value in this case is going to be the -6. So we'll place that there. I'll put the y in the middle because we know it's going to be in between the low and high points. Now the highest y value, which is over here, because you can see there's nothing higher than this point here on this graph, the y value for that is 2. So place the 2 there. Now there aren't any real defined endpoints for these y values, but because you have a continuous line going through both, you can write it as less than equal for both. If it were a dashed line, then you would not include the equal sign.
In other words, guys, the only time where it's not included is when you have an obvious open circle or infinity.
Anyways, let's look at the last graph. We have a bit of a semicircular thing going on. So, same as last time. Let's start with the domain. What's the furthest left point? Which is, we can find it to be right here, and the furthest right point, it's right here. So, domain, x values. What are our x values? At the leftmost point, what's our x value? It's the -5. So -5 goes down here. And what's the furthest right value for the x? That value would be 5. So, have those down. We need to define whether or not those points are going to be included or not. Because the points are closed, they are going to be included, so we'll write less than and equal to for both. Now for the range, we got to establish our minimum values and our high values. For this one, it's a little, I guess, it might catch you a little bit because there are 2 points that show low values, but again, you're just looking at the y value. Because these coordinate points have the same y value, there's no need to feel too confused, because the y value for these is simply 0. Because this point is -5, 0, this point is 5, 0. Same y value, same low limit. Now for the high point, which is up here, the coordinate point is 0, 5, so the y value here would be that 5. Y in the middle. Now, as for the signs that go in between the numbers and the y, are they included in the graph? Because the low point has those closed points, and because the line is continuous at the top, you can also put less than equal for both sides. Okay, so for number 7, it says a basketball team has 10 team members. The table below shows the number of minutes played in a 32-minute game and the number of days of practice missed. So you can see here, the table shows that left column number of minutes played, either more than 25 or less than or equal to 25 minutes, and the number of days of practice missed. And it has a value for each of the 10 students listed here. See, 4 up here, 6 down here. So now it's asking, what conclusion about the team members is true? Let's look at the first one. Players that played greater than 25 minutes missed more than one practice. So let's look at the top row here, because this is the column that displays, or the row that displays more than 25 minutes played. So looking at the number of days of practice missed, there were 4 students. One missed 0 days, another missed 0 days, one of the players missed 1 day of practice, and the 4th one missed no days of practice. So, looking back at the statement, players that played greater than 25 missed more than one, keyword here being more than one practice. In this sense, it would be false because they all missed either 1 practice or fewer. So, answer choice F would be incorrect.
Well, duh. Alright, so again, multiple choice, just read the options. Thank you, Jimmy. Alright, so again, here's 4 different people. So letter G, all players that were at practice every day played greater than 25 minutes. Well, this guy was here at practice every single day, but he still played less than 25 minutes, so that's not really true. So maybe he just really sucked. I don't know. Poor guy. Alright.
It really sucked.
Players that played greater than 25 minutes missed 1 practice or less. It has here all of them have either they didn't miss any days of practice or they missed 1. You could even look at J. This one would be false. Only 1 player missed only 1 practice. Well, clearly we have 2 people here that missed 1 practice. So that is false.
Why you kick me out of my chair?
Go away. Anyway, last problem for part 1. Number 8. The basketball team is ordering t-shirts to sell for a fundraiser. Here's my 2 variables. Number of shirts sold and team's profit. What is the dependent quantity in this functional relationship? Alright, as you can see through the answer choices, we have dependency statements. Remember guys, the first variable is going to always be your dependent variable. The dependent, it depends on the independent. They give you your 2 variables, the number of shirts sold and the team's profit. Our goal is to see, hey, which dependency statement is true. So which one is dependent, which one goes in the independent slot. I'll show you guys a cool way to remember or to spot which one is the independent and dependent variable. Alright, so in your function f of something, even though it's not x this time, this is your y quantity. F of x is the same thing as y. That means that this letter inside this parentheses, that can also represent x. And remember guys, x is always independent. Knowing that n is my independent quantity, we remember that n represents the number of shirts sold. So that means the number of shirts sold needs to be on the last blank. So right away we can automatically eliminate A and B. Because hey, on the last part, they have the sale of the shirts, which is not the number of shirts, and they have the profit from the sale, which is, again, not the number of shirts sold.
It also says something about cost, and it doesn't even mention that in the question at all.
So, again, our two variables are the number of shirts sold and the team's profit. The only other one that has the team's profit as the other variable is letter D. The amount on letter C, the amount the team paid, that's not even a variable, so we can automatically cross that out. Alright, so your answer would be D. The team's profit from the sale, it depends on the number of shirts sold. And that makes sense. How much they make, oh, it depends on how much they sold. Alright, so that is the end of part 1 for your midterm review. Good luck. If you have any questions, I am Sensei. If you don't have me as a teacher, if you have me as a teacher, well, you know where I am.
Come to tutoring. I might be there.
Also, ask Miss Elizondo or even Miss Bettis. They will help you. They are awesome. Alright. Goodbye. Have a wonderful weekend. Okay, let me begin that again. What's it? Stop it!